It is a logical principles or patterns of reasoning that allows us to draw valid conclusions from given premises. They provide a systematic and reliable way to make logical deductions. These rules are used in formal logic to establish the validity of arguments and to prove theorems. Here are some common rules of inference.
In propositional logic, modus ponens, also known as modus ponendo ponens, implication, elimination, or affirming the antecedent, is a deductive argument form and role of inference. It can be summarized as P implies Q, P is true, therefore Q must also be true. The form of a modus ponens argument is a mixed hypothetical syllogism with two premises and a conclusion. If P, then Q. P, therefore Q. The first premise is a conditional, if then, claim namely that P implies Q. The second premise in assertion that P, the antecedent of the conditional claim, is the case. From these two premises, it can be logically concluded that Q, the consequent of the conditional claim, must be the case as well. An example of an argument that fits the form modus ponens. If today is Tuesday, then John will go to work. Today is Tuesday, then therefore John will go to work. Propositional logic, modus tollens, also known as modus tollendo tollens, and denying the consequent is a deductive argument form and a role of inference. Modus tollens is a mixed hypothetical syllogism that takes the form of FP, then Q, not Q, therefore not P. The form of a modus tollens argument is a mixed hypothetical syllogism with two premises in a conclusion. FP, then Q, not Q, therefore not P. The first premise is a conditional if then claim such as P implies Q. The second premise is assertion that Q, the consequent of the conditional claim, is not the case. From these two premises, it can be logically concluded that P, the antecedent of the conditional claim, is also not the case. For example, if the dog detects intruder, the dog will bark. The dog did not bark, therefore no intruder was detected by the dog.
Hypothetical syllogism is form of deductive reasoning and logic that consists of conditional statement and conclusion.
It may be also written as P implies Q and Q implies R, so therefore P implies R. So let's take an example. If you practice a musical instrument, then you will improve your skills. If you improve your skills, then you play better in the orchestra. So therefore, if you practice daily, then you play better in orchestra. This means that if both first and second statement are true, the conclusions or the third statement will be true as well.
Next is disjunctive syllogism, and it asserted at least one premises is considered to be true.
Let P or Q, not P, be the statement. The election will be won either Team Maasahan, the incumbent candidate, or the new challenger Team Kaagapay. The incumbent candidate did not win, so therefore, the new challenger, the Team Kaagapay, won the election. So, if P is true or Q is true and not P is false, then probably Q is true.
The addition rule in logic is a rule of inference that allows us to introduce a disjunction or into an argument. It states that if we have a premise P, then we can derive the disjunction P or Q, where Q can be any preposition.
The addition rule is based on the idea that if we know that P is true, then we can also say that P is true or Q is true. It allows us to add any proposition to a premise. This rule is useful when we want to expand the possibilities or options in our logical reasoning. Let me give you an example. Premise, it is raining. Conclusion, it is raining or the sun is shining. Using the addition rule, we can introduce the disjunction and expand the possibilities. In this case, if we know that it is raining, we can also say that it is either raining or the sun is shining. The simplification rule in logic is a rule of inference that allows us to simplify a conjunction and into its individual components. It states that if we have a premise P and Q, then we can derive the individual propositions P and Q. The simplification rule is based on the idea that if we know that a conjunction is true, then we can also say that each individual component of the conjunction is true. Let me give you an example. Premise: Maria is a good singer and Maria is intelligent. Conclusions: Maria is a good singer and Maria is intelligent. Using the simplification rule, we can derive the conclusions by breaking down the conjunction into its individual components. If we know that Maria is both good singer and intelligent, we can infer that she is a good singer and she is intelligent.
So, rules of inference, conjunctions. For example, the rules of simplifications and conjunctions emerge directly from the fact that when two sentences are connected by conjunctions, what's being asserted is that both conjuncts are true. Thus, if a conjunction is true, we can derive either conjunct. In addition, if we have two sentences that are true, we can join the two together using a conjunction.
Conjunction allows you to build statement. So if P is true and Q is true, so that P and Q must be true. For example, P is like Lisa likes cheese and the Q is Lisa likes cheesecake. So you can conclude that Lisa likes cheese and Lisa likes cheesecake.
The definition of resolution is a fundamental rule of inference in professional logic as first-order logic. It is used for proving the validity of a statement or fighting the negation of a statement by showing that its negation leads to a contradiction.
Let P be it is knowing, and let Q be I will study this great math. If it is knowing, then I will study this great math. It is knowing, therefore I will study this great math.